Kia ora and welcome to this video on question 3 of the 2022 Scholl Calc exam. Part A is a differentiation problem, Part B is a related rates question, so again a differentiation, and Part C is finding the maximum length of something, so an optimisation problem. The whole question is differentiation. Let's jump into it. Okay, question 3A. Quite surprising for scholarship because it's really just an achieve problem on steroids. We can brute force it, or we could use the hint. I'm going to brute force it just to show you how nice the hint is. But before, if I want to differentiate this expression, I would need the quotient rule and I'd need the product rule on the numerator. But because both of the functions e to the 5x and e to the root x plus 1 have the same base, we can simplify that first and avoid the product rule altogether. Sorry, avoid the quotient rule altogether. So if I've got f of x, I can subtract the powers e to the 5x minus x plus 1 to the half, and then that's all times by root x plus 1. Okay, no longer need quotient rule. F dash of x, I need to differentiate the first term and then times by the second. So differentiate the first term, I get the same thing multiplied by the derivative of that thing, a derivative of the power. Times by the second function, plus the derivative of the second function times the first function. Okay, and all I've done there is used the product rule, because I've said this dude here is u, this dude here is v, this dude is, actually no, not that, this whole dude here is u dash, this dude here is just v, this dude here is v dash, and this dude here is u. So product rule. Now we just need to sub in 0 and be real careful. F dash of 0, the first term, when we make x 0, we get e to the 0 minus 1, so e to the minus 1. The brackets, we get 5 minus a half. And then the last thing we get times 1. In the second term we get a half times e to the minus 1. So we've got 5e to the minus 1 minus a half e to the minus 1 plus a half e to the minus 1. And those terms of course cancel and we're left with 5 over e. Okay, so product rule, not too bad. If you use the quotient rule, it's even messier, but because of those terms having the same base, we could simplify first. Using the hint's actually really nice because logs turn products and divisions, quotients, into sums and differences. So if I just use the hint and log both sides, the log of f of x is going to be the log of the stuff now, like I was saying, log of AB is log of A plus log of B, and log of A over B is log of A minus log B. They're the rules I'm using. So I get ln of f of x is ln e to the 5x plus ln x plus 1 to the half minus ln e to the x plus 1 to the half. The natural log and e to the power are inverses of each other, so those cancel and those cancel. And also, the half there, I can bring the half down the front now that I've got a log there. So I get a half ln x plus 1 minus x plus 1 to the power of a half. Now we differentiate implicitly. The left-hand side is a log of stuff. Log of stuff differentiates to 1 over stuff times the stuff differentiated. That's the hint. Okay, 1 over fx times f dash of x was the hint that was given in the question. It's quite a common scholarship problem, actually, this implicit differentiation. And we differentiate the right-hand side, we get 5 plus a half times 1 over x plus 1 minus a half x plus 1 to the negative a half. Therefore, f dash of 0, if you sub in 0 into that right-hand side, the only thing that's left is a 5, because you get a half minus a half. So it's 5 times f of 0. Go back to the original expression, and f of 0 is equal to e to the minus 1. We have the same answer as before. Okay, part B. A coffee filter machine can be modelled using a conical dripper and a cylindrical flask. One model is shown. The conical dripper has a height of 18 and a diameter of 18. Cylindrical flask has a diameter of 18 and a height great enough to ensure no overflow. Things will get complicated if that was the case. Waste of coffee too. Coffee drips from the dripper into the flask at a constant rate. What is the ratio between the rate of change in depth of the coffee in the beaker? What beaker? Oh, the flask is a beaker. Okay. Beaker / flask. And the rate of change of the depth of the coffee in the dripper when the depth in the dripper is 9. Okay, so we need a few variables to sort this one out. The rate of change in the depth of the coffee. So if I call the depth here h, that'll be the first thing I do. For the cylinder's an easier one. So, got some coffee in here. Just talking about that stuff. It's h high, and we want dh dt. We know for a cylinder that we've got the volume is pi r squared h. But for a cylinder, the radius is constant. And we're told that the radius is 9. So we've got 81 pi times h. dv dh is equal to 81 pi. And to find dh dt, we need dh dv, which we can get by just flipping that formula that I've just derived upside down, multiplied by dv dt. And we're told in the question that dv dt is 50. If the coffee is dripping from the dripper into the flask at a constant rate of 50, it's leaving the cone at 50 and it's coming into the cylinder at 50. So we've got 1 over 81 pi times 50. That's the rate for the cylinder. Now the cone is a bit different because the radius of the coffee is changing. As the coffee leaves, the radius of that cone decreases. If we call that r, we know that the diameter is 18, so the radius is 9. And we know that the height of the cone is 18. So similar triangles tell us that if I put h in here, like I did before, the h is equal to 2r from similar triangles. The volume of a cone is 1/3 pi r squared h. But if I replace r with h over 2, the reason I replaced r rather than h is because I want dh dv. I don't want any r's in my expression. So that one there is equal to pi over 12h cubed. dv dh is equal to pi over 4h squared. And then dh dt, the rate that we're trying to find, the rate of change of the height of coffee in the dripper, is equal to 4 over pi h squared times by, again, dv dt, but in this case it's negative 50. And the question said when the depth in the dripper is 9 centimeters. So now we can make the depth 9. You get minus 200 over 81 pi, because h is 9. Okay, ratio. Which one's first in the question? The rate of change of depth of the coffee in the beaker. So the beaker should be first in the ratio. 50 over 81 pi. Dot minus 200 over 81 pi. And then with ratios we can multiply them through by stuff. So here we go. 1 to negative 4 is the ratio. Or a quarter. Or 0.25, something like that. Alrighty, third question. The diagram alongside shows a sector of a circle with radius r, centre A. We've got some angles in here. The diagram's a little misleading. This side here is actually parallel to that side. It just doesn't quite look it. And the reason for that is we are actually told in the question, points E and G move so that EG remains parallel to AB, meaning that this is a right angle. Corresponding angles on parallel lines are equal. And also because this length here is R, it means that we have a similar triangle situation here. E is a point that's moving, so I'm going to call this length here X, the distance from A to E. This is r minus x, and this length is also r minus x. Okay, angle BAC, the side BA and the side AC are equal length, which means that the side here and the side here should also be equal length for similar triangles. The key bit of insight in this problem is realizing that you have a right angle triangle here, and Pythagoras applies. AG is equal to R as well. So we have, let's call GF equal to Y. So we have Y plus R minus X all squared. Did I say all squared? I meant all squared plus x squared equals r squared. So that's our connection between the length FG, which we're trying to optimize. In this case I called it y. A constant r, just the radius of the circle, which we could make 1 and then just multiply our answer by r, scale it up. And then x, our thing that's varying. So if I expand this out, that's the equation that I'm going to use. Expand it a bit further. Cancel off the r squared term. And I want to make y the subject of this equation. So I've got y squared. Oh, do I really want to do that? If I want to make y the subject of this equation, it's a quadratic equation. So I need to rearrange and use a quadratic formula, which is a bit messy. So instead, a much easier approach would be just to use Pythagoras on that triangle without calling the thing y. Just find the length GE. Length GE is going to be equal to the square root of r squared minus x squared. Much simpler equation. And then, therefore, the length of GF will be root r squared minus x squared, take away the bit FE, which is r minus x. That would be the equation I would have got to if I'd solved that quadratic. Real tedious though. And this is equal to y. So dy dx is equal to be careful here, differentiating minus r, it cancels, and we've got minus minus x, which differentiates to plus 1. Tidy this up a little bit. I'll cross multiply the thing and then square both sides. That means that x squared is r squared over 2. So x is equal to r over root 2. Assume that that generates the maximum length. And then we want to find that length. So we sub that back into the expression up here. R squared take away x squared, which was r squared over 2, minus r over root 2. It's r over root 2 minus r. What is it? Doesn't seem right. Oh yeah, no, that's right, because it's plus r over root 2. So we've got two lots of r over root 2, which is root 2r, minus r, which is root 2 minus 1, all times r. Now, I found an easier way to do this problem that didn't require differentiation like that, although that was quite tidy in the end. If we just look back at the problem, this triangle here is a similar triangle. And we found that before we were saying that this side here, let's call this A, and this side were the same, and that was a 90-degree angle. So this is 45 and 45. Then vertically opposite, this is 45. And make that 90, and that's 45. And if you call this point, what letter of the alphabet have we not used yet? H. To find the biggest length of FG, because this right angle triangle is set up in this way, GH over GF is the sine of 45 degrees, which is 1 over root 2. So rearranging that, GF, the thing we're trying to optimize, is equal to root 2 times GH, the biggest value, biggest GF will occur when GH is biggest. And if you think about where that could be, as you move the point E, G obviously moves. The biggest value of GH is going to be right at the bottom of the arc there. And so we just need to find that length. I'm just looking at a GeoGebra diagram that I've made for this. If I move E, FG is currently 0.29, but if I move E and lock it in right there, that is the longest value of FG. It starts, why does it keep doing that? Cool, so it's right there. And to find that length, we just use trigonometry, and you can find that it's root 2 minus 1 times r. I'll leave that as an exercise for you guys. That will tell us that FG equals root 2 minus 1 times r. Catch you in the next video.